All right. Yeah, so this is a talk on property testing, which I will introduce in the course of this talk, just here, because the previous talk was at Pivotal, it was a while ago, and obviously not everyone's going to see it. So I'm going to introduce property testing while also having this mostly be a draft report of the use of Stream Data, the property testing library in Elixir at my last job, which I finished up on Friday. Slightly awkward, but whatever. Hi, my name is Rob. I've graced these kitchen tile boards before, but I'll do it again for the sake of property testing. These are our two cats. These are also our two cats. And this is the topic of this evening. So what is property testing to start with? And then we'll get on to how I actually used it in my last job. And it's fair to come in with this kind of question mark because property testing isn't something that's frankly kind of usual. It's still like on the fringes in terms of something people are being aware of, and certainly recently sort of popped up in Elixir itself in a more visible to most of the community kind of way. And as such can be kind of intimidating as a sort of a method of testing, because it's kind of a bit of a black box when you've never seen this stuff before. You have to kind of think a little bit differently. Everyone talks about it kind of weirdly, so it's just a little bit, yeah. Anyway, I'm going to start at a regular old test, and we're going to work our way through to property tests just to make it easier. I've got a module called word count, and it's got a function called count, and you don't need to know what's inside it so long as this is just, this is how it behaves. And this is a passing test for the sake of example. So feed it some text, you get back the number of words in that string. Cool. This is a regular test, X unit, this is plain whatever. So let's reform this a little bit. We say if we have a group of words and then text is made up of these words that have been joined together with spaces. And then we put it to the word count function and it comes back as 7. It's exactly the same as before, it's just we've decomposed, we've pulled apart some bits of our data that we're going to feed to our function to make our assertions with. So we can pull that apart even further. If we want to make it a little bit tricky, if we want to randomize this a bit so that we are testing different things every time we run this test, and remember, it's only running once, then we can pull it to a separate function that generates a random word, and then we're going to, for example, come up with a word count that says how many words do we want, and then we're going to do some processing on it, give it to the word count function, and then we're asserting that we get the appropriate words out given what we tried to we basically generated a bunch of words, we generated word count number of words, and then we're asserting that the result is the word count number of words. We're basically generating data, giving it to a function, and then checking the result. And this fundamentally is what property testing is. So property tests, we're going to use stream data to swap it over to this, which is very similar. So stream data X unit properties is the module that stream data provides. It's the name of the module, and it gives you much in the same way. Test is, I think it's a macro. I'm not really sure. I'm not sure about the property specifically, but it's a thing that you write, and it indicates that this is a property test. And then we've got this check all macro, which is basically like with is a macro, and it's sort of defining a bunch of these different things that we're going to generate for our test. For example, we've got a count, which we are saying is a positive integer. We have a generator, which I'll describe in more detail in a bit, that will say that will give you back a positive integer when you use it with this check all thing. And we've got words, which is a list of our word generator at the very top there. And we're going to use count and words in our property test to assert something is basically the same as our previous test. It was a regular test that ran once, generated some random words, and asserted the thing was correct. And here we're just doing it a bunch of times. This is going to run by default 100 times using the stream data library. You can muck around how many times, but yeah, it's kind of a thinking about tests in a slightly different way. So you write a general rule that should apply across the board, and you generate data and you give it to the function and make sure that that rule holds. Basically, you generate data with a particular assumption, for example, bunch of words, and then after putting it through the function, we assert that the count matches the number of words we generated at the beginning. But anyway, stream data itself is a library. What you hide is the GitHub account. And it was slated to be part of Elixir 1.6. they want to use it to test some bits of Elixir itself. And so like, okay, in order to do that, we need to pull it into the core. And then I found out 2 days ago that it's not going to be part of core, and I'm not sure what happened with that or the timing of why or announcements and stuff, because this is all a bit new to me. But anyway, it's not going to be in core, it's going to stay a library, whatever, and you may either be, like this, or you may be like this. Look, I don't mind. You could just flip the yawn comma with whatever order is applicable to your reaction to it being in core or not being in core. But as I said, I'll talk a little more about generators in more detail, and that's what we're going to do for this next little section. So a very, very, very simple property test. We've got example, which is going to be our generator that we're going to use in our test. We're going to use the generator to generate a string, hello world, and then inside our test, we're going to assert that the string we generated is hello world. It's ridiculously simple and not at all a useful test, but shows you the structure of things and what lets you get more familiar with the concepts. So we've got constant, which it takes a string and returns a generator of that will always return, when used, that will always return that particular string. And if you're familiar with the dialyzer specs at all, this is the literal spec for that chunk of data. It's a value that represents potential strings.
Is that going to test the same thing 100 times?
Correct. That will produce hello world 100 times, and it will assert that it's 100 times. It doesn't automatically collapse the test cases. It's going to be the same every time. That would be a little bit too hard. Whatever. In this case, this is because it's a ridiculous test. It's going to be definitely silly to run this 100 times, but as we get more complicated stuff, it'll become a little more sensible. But yeah, so that's our generator value. And I covered what constant was. Cool. So we have more sensible generators, like for example, member of, which is something that will take a list of things and will produce a generator that, when you use it, will give you back one of these things. So you'll get hello, in this test example below, you'll get hello or world or Tokyo or Perth. And it so happens this test is making sure they're all, again, this is a ridiculous test, but it's making use of the different generators. We've got the word generator that inside the test is available as the variable name a word. And then we can start building up these things. These things compose, generators compose together. And so we've got this, for example, member of with the list of words, and then we've got a list of that uses the previous generator. So words is now a generator that that when you use it later will produce a list of strings that are members of that array. So we start gluing these things together into larger and larger generators. So you got list of words and etc. We can just keep building them up. And there are different ways of writing these sort of composed generators. This is we're going to rewrite sentence to make use of the member of and the list of, and that's all the same. But we're going to use another macro called gen all, which allows you to, for example, feed in some macro. So feed in a generator and then make use of it in the block below. So if we've got the words generator, and then we're going to have it available as just the words variable inside this. And we're going to do some stuff to it. We're going to join the words together with a space. We're going to capitalize the entire sentence. We're going to add a full stop on the end. That little help is there a nicer way to do this? Because I hate this, but I don't know if I've missed something in the last 6 months I've been writing Elixir. Help? Anyone? No? Okay, cool.
String interpolation?
Yeah, that would do it. All right. Hey, I found out you can do pipe case do the other day, so I'm plainly missing a bunch of the basics.
You can do kernel.
Kernel?
Kernel dot and
Okay. I will try this later. Okay, cool. So anyway, this is, and the result of this block that we've got here will become the generator result when you use this generator called sentence. So you call sentence as a function and you get back a generator as a value that you can then later on use to generate values. Cool, so we can make this a little more complicated. We can use a couple of different things so that our generator is not just making use of words. So this is making use of the words generator, but also using the member of generator to basically pick an ending of the sentence, like a full stop or an exclamation mark. And this might be a way of testing sort of further edge cases. You start generating sentences with particular shapes that might be a little bit unconventional or just maybe unexpected if you happen upon an edge case. But yeah, so we've got a generator that's now composed of two other generators, and we just happen to use this gen all macro to make it nicer to read, basically. There are ways of writing this manually. I prefer this version. Cool. And so a more real-world generator is, I'm sorry for the tiny text, I really couldn't squish it down any further, was basically just something here that generates a naive date time value that is composed of a date and a time generator, which are in turn composed of a year and something which is generating a number of days in that year. And the time one is generating numbers for hours and minutes and seconds. And it's all gluing it together as a value, and you get naive date time out at the end. So that's from production code. Maybe I shouldn't be putting it on screen. No. But yeah, I mean, this one will work. It's very easy when very easy to try to tie yourself in knots, particularly when it comes to date time generation, because you're like, oh, I'll just generate the number of months as 1 to 12. Like, wait a minute, the 30th of February doesn't exist, and et cetera, et cetera. This is a little trick I learned from when I was doing stuff with Haskell, which is you generate the year, fantastic, and then you generate a number, which is the number of days, and you just use the function, one of the functions that lets you say, on this year, the 265th day, produce the date for that, please. And it just means you're just choosing a range of days within a year, and it just so happens you get February 29th sometimes, which is nice because it checks some of the edge cases, rather than you just start having to throw a bunch of numbers at it and then removing a bunch of cases which are wrong, which is problematic. Cool. But anyway, all the different kinds of little combinators and things you can find on the Stream Data API site, and that's pretty detailed. It's got an awfully big section about writing stuff like this, like writing generators using these different pieces together. And yeah, I would definitely recommend having a read through that if you even just the idea of, even if you're just becoming more familiar with how generators might be composed, or what a system composed of a whole bunch of little combinators might look like. But yeah, onto the experience report bit of this talk, which is, the things that worked, the things that didn't, and just other stuff I ran across while I was at it. So, generator pitfalls. I've had this multiple times when I was learning to do property testing at Ambiato when I was running Haskell, and now, I've re-explored the same mistakes, and I've made new ones while doing this stuff at Cancer recently. So one is the size of generated data. Cool. Back to one of our previous examples, we've got we've got sentence, which is a list of words, and this word is a list of word, and then a word is one of these values, which is all fine. But when you because these things are nice, pure, these are pure functional combinators, you can rearrange them. In this case, this is strictly equivalent. Fantastic, cool. So there's something about this generator that looks a little bit unfortunate, and that's this little bit. List of a thing is, if you're familiar with this fellow, it unfortunately leads to slowness, and which is the very opposite of what this diagram is trying to lead you to believe. This is very much not where you want to be. So because you end up with a list that was, I wrote this stuff. I wrote an example for this talk where I was writing the sentences, and then I very quickly produced a thing where I was trying to test something with the date generator, and I had a string generator in there as well. And I ran the thing 500 times because I really wanted to try to find this date time edge case, and just got slower and slower, and then blew the database time out. It's like 15 seconds, we blew that test time out because I had accidentally made something quadratic. Great. It's not a good place to be, and it's very easy to accidentally do. And sometimes it's you need to sort of come up with some combinators to try and tamp things down a little bit. This is kind of on the hacky end, but it's kind of what people in real world with generators tend to do, which is writing combinators like I've got a smallish combinator that I could potentially use that will take a generator, another of these values that represent values that can be generated, like a generator of strings if you were to use it later as an input, and then what we can do is we can rescale it. So when we're generating this data, what it does is it starts it with a size number that starts at 0 and gradually works its way up. So you end up with a list, for example, that starts at 0 items long, 1 item long, whatever, up to 10 to 100 or whatever the scaling value is. This size value jumps up and down to determine the size of the object you're kind of generating. And so a scale is a way of saying, well, that size number is great, but for this generator and inside this generator and everything inside it, for example, the list of stuff, I want the size number to be a little bit different. So this rescales the size number down to be logarithmic. So it starts, it generates who knows a logarithmic curve off the top of my head? Because I honestly can't remember. It's like 2, they say like 1, 1, 5, 7, 8, 9. So it just starts looking like a curve like this. So you don't get a massive structure. You don't get a linearly massive structure. It's a case of you get something that kind of taps off pretty early, and you end up with a very small list, but still sufficiently big to test a bunch of things. Sorry? Oh yeah, sorry, that was an alias. Sorry, I've got through my code, and I usually alias stream data to SD because I like namespaces. And similarly, I've got a biggish thing where I want to generate a shitload of things intentionally, and this is just a way of just multiplying whatever the size number is, make it bigger. So you still get your 0 case, because 0 times 99 is still 0, so you still test your empty case, but you very quickly get into the stratosphere in terms of large numbers, which is appropriate for certain generators. Generators are something you custom build for your particular cases that you're testing. So a second pitfall when it comes to generators is reconstructing information after the fact is tough, so please do not do that. What I mean is I wrote this example for a slide and then realized I had made this goddamn mistake again. I had generated a sentence, which is fantastic, made up of this random number, 1 to 10, whatever words, etc., etc. That's cool. I finally get to this line. I try and write, wait, what is my test? I don't know. It's a sentence. It may be 20 words long. I have to write the word count function again in order to make sure to come up with the other side of this assertion. It's like, oh god, I fucking did it again. So what you do is, as per my other thing is, the previous thing is, you make sure you sort of have an input that you generate and control, which determines the size or determines the something that you keep hold of that you can then test again at the end. For example, instead of just generating some words, I instead chose to generate a particular number of words such that I can go and test at the end that the number of words that I generated matches up with, the output matches the generated input, but I've still got enough control of the input so that I can come up with a useful assertion at the end. Because frankly, the biggest problem with property tests is coming up with useful assertions, trying to think about your program in ways that are sort of generalized properties, like you can repeat something twice, or you can reverse it, or stuff like that, or but it's just, yeah, one of the pitfalls. You very readily fall into this kind of thing, even if you've done it a bunch before. My third generator pitfall are things involving time X and or time zones specifically. It used to be times, particularly round tripping to a database. You'd have too much precision on a timestamp, and Postgres would lose some of it. So you go and you generate an item and you send it to the Postgres and you pull it back out and you make sure it matches the original, and then the times are different because the numbers are chopped off. That I haven't run into that problem in a long time, but this is something I ran into last week where naive date time and stuff is fine. This example you already saw, to be clear. But if you start generating things using timex and using the time zone things, timex.toDateTime, I think is the function, you can end up accidentally generating ambiguous date times where you round trip, you put your thing through the system and pull it back out again, and you end up with an ambiguous date time because there are certain gaps where daylight savings changeover and stuff happens, and timex says, you know what, it's too hard, and we'll give you back something that can represent one date or another date, and it's definitely not the same as the original that you put in there, because what you generated was accidentally wrong or accidentally an impossible date, and timex is just trying to handle your shit somehow, and this is what it chose to do. Sorry, this is getting progressively more sweary. I'm very sorry. You can just remove it from YouTube if you like. I've been having water. I'm not even drinking. All right. Cool, so round tripping, an experience report. This is pretend I have a glass of whiskey in my hand because that's how I feel. No, so round tripping is actually a useful thing to do, and I realize I should have explained this a little bit before using round tripping as an example. But round tripping is basically where you generate an original thing, and then you go and put it through a function that takes it to one direction, and then you pull it back through another function. For example, JSON parsing and generating is my favorite example. So for example, we've got a health report, in this case, just some domain model thing that is a map, and I've given it to, notice example health JSON, as in it's we're not talking about JSON in terms of strings, we're talking about the value that poison gives you or takes. which is, like a list of maps or a map or a whatever, as opposed to literally raw strings. But the principle is the same, where I've got something that will take a health report and generate the JSON-ish representation, the raw data representation of that, and something that will take that raw data representation and pull it back to a domain model, the health report, and it should be the same as the thing I started with. Generate, pass, it should be the same as the original. Yep. So it's a round trip, and I've got two different variants because sometimes I want things with IDs, and sometimes I don't want things with IDs. It just so happened that, this is what I needed for this particular case. And in some of the bits of my code, I have stuff that looks like this, where it's a case of I've got code that is written to pass JSON, like pass this structure and turn it into a domain model, and I have stuff that generates it for representing back to users for a REST API or something. So microtangent, Phoenix doesn't seem to be built for this, or rather Phoenix does not tend to be used in a way that is conducive to this setup. You have to go off the beaten path in order to get something like this, where you've got this JSON, this parsing and generating as a thing. Phoenix and Ecto seem to, the way that Phoenix tends to be used is with Ecto in such a way that it's bonding your API contract with the outside world to the structure of your database models, or at least, because the Ecto change set is very built to take data of a particular shape and then give it to bits of the database. So you can work around this, you can add your own layers, etc. It's just unfortunate that I'm so used to be able to do this and get the value of property testing API contracts, but I can't because no Phoenix code is idiomatically written in a way that would let me do this. You end up with wildly divergent paths where your change set is your parsing, and you've got some render functions for your dumping stuff out as JSON, and I don't know how to combine the bits to make it look like a regular Phoenix app while still taking advantage of this test. I would really appreciate a long conversation about this with someone afterwards, because I am going to be using Elixir at my day job, and I don't want to make a horrible mess for whoever I'm working with. And I would also like to take advantage of some of the stuff I've been able to use for the last 4 years, but I don't know how within idiomatic Phoenix. Microtangent over. I promise I'll get on with it now. Cool. So idempotency, also like doing things twice and getting the same result as doing it once, I think. Is the, yeah? Okay, cool. All right. I think that somewhere there's a guy who I know defines idempotently differently, is probably yelling at me, but I can't hear him, so it's all right. So here's a controller test written out in abstract because I don't want to have this massive thing. But basically, you generating using property-based testing stuff, generating the models. You insert the models into the database, or whatever. Sorry. Please remove insert models. My brain fart when I wrote this. But we're basically making a controller request to the server with some model with some record to insert or whatever, and then we make it again, and then we retrieve the models, and then we assert the expected result. With the idea of testing that, in this particular case that I realize I haven't actually outlined, is that I've got a mobile client. The mobile client has the network. Networks are particularly shitty when it comes to mobile clients, and you want to make sure that trying to do a double insert of the same report is going to be the same as if you're doing it once. It's not overwriting data, not changing timestamps, not anything. It's a case of, I already got this, it's cool, we're just going to leave this. And so what I want to do is, using a property test, is write a controller test in the usual sense, but run it a couple of times to make sure, and in particular, run it 1+ times. Does something go wrong if you run it once? No. Okay, cool. Does something go wrong if you run it twice, 3 times, 5 times? So it's basically something you can parameterize. Not only sort of effectively generating a random factory to produce a model that we want to send at the server, we're also generating the number of times we want to attempt that, and we still want the same result. It's a property. It's something that we can repeat and make sure that the end result matches what we want. So we've covered the +1 controller bit. Unfortunately, there's a little bit of this here, which is a 1-minute cleanup in a test, like removing database rows, and it all comes down to shrinking. Shrinking is the idea of replaying a test and backtracking on the input data until the test starts passing again. So let's say if you've got a function that takes a number and it does something valid on numbers below 5, but it breaks if you give something above 5. It breaks in whatever nebulous fashion. So you give it 1, it works. You give it 3, it works. You give it 9, kaboom, it's gone, it's broken. All right, let's try 8, kaboom, 7, kaboom, 6, kaboom, 5, kaboom, 4. It passes, cool. using my shrinking process, I'm replaying this test with different inputs just to see what passes and fails. And when we get to that 4, we know that's the last passing one. So I go backtrack a step. 5 is the smallest possible number that this particular function will break on. It's a way of shrinking data down to the smallest possible case so that you can deal with a small test case as opposed to a massive test case that happens to break in the same way. But XUnit properties runs inside a test case. DB data is not you don't make use of the regular DB transaction stuff or the DB sort of test hook stuff because the data isn't reset between runs, so you effectively need to manually clean up your stuff between test runs. You need to go and, just in case it blows up when you make your assertion, and now you've got all this extra stuff in the database that may complicate your test results. So if it matters, if you don't actually care about having extra records in the database and it may change the result, then you need to do a cleanup step, then assert things are correct. It's like, oh, great, cool. Well, I found that out the hard way, but fortunately I found it out. On to other problems. Shrinking woes, speaking of which. Shrinking works a lot of the time, sometimes it doesn't. And I couldn't figure out why, and I didn't have time to figure out any more, and so I ended up with just, okay. It fortunately has a nice little diff, it'll give you a green and a red. Sorry, colorblind people, a little green and red sort of diff where it'll highlight little bits of the string, like the left and the right, the 2 bits of the equal comparison. Like, I think this is XUnit itself. Will give you the comparison there and will highlight little bits of the string, but if the string is massive, then it's not very friendly to deal with. So this is still a black box to me as to how the shrinking works. I've tried to dig into it, I ran out of time to do so. I am not confident. I really want to learn more about it if I want to use this more in real world sort of scenarios. And I'll come back to the sort of scenario I'm using this at the very end of the talk. But there's another thing, factories like a ThoughtBot, I think. Okay. Factory, sorry, something like it. Basically, factory bots Elixir counterpart that I can never remember the name of because I've never had to install the library. X Machine. Okay, cool. So the factories are defined in a particular way, and you define generators in a completely different way. And so what do? Do you have both? Do you write something that'll do an automatic conversion? I definitely did not have time to do that in my experiments. I'd love to know how people tend to deal with this in their apps, because I ended up with like a small parallel set of health report had a generator and also a factory for regular tests versus, and you can use the stream data stuff. You can write some helpers that basically just takes over this factory's library's work, which is fine. It's just you start replicating bits, it starts swallowing things. I don't know how to have them live side by side very well, and I haven't run into other users of stream data in production yet, so I don't know how things tend to be done in Phoenix apps with stream data in this regard. Cool. Macros are something I'm not particularly fond of. I would argue that macros, unlike functions, don't compose particularly well. For example, check all is a macro. Check all takes an option called max runs. I don't want to have to either keep on providing the max runs thing or keep providing a 10. I can abstract this out to module attributes or a function I keep calling. But the thing is, because check all itself is a macro, I'm used to having a function like a test function that I can pass to another function. Can I have a function that is kind of like a shortcut, like a slow check kind of thing, that will allow me to sort of automatically set some settings and things like that. But I can't do that because check all is not a function, check all is a macro. So I need to start doing this stuff to figure out how to automatically set defaults. And I got about 5 minutes into this and realized I don't really want to be writing macros for this. And I just ended up having a max runs 10 in the 10 test cases I wrote for my experiment with this in the app. But I'm sad when it comes to trying to write this stuff, because I know it could be functions, but because of the syntaxy stuff, it's a macro, but therefore you need to do this stuff to work with the macros. And there's a lot of stuff in Elixir that uses extensive use of macros, and it makes it very difficult to work with because you need to start modifying AST as opposed to taking values as arguments to functions and returning arguments like functional programming intended. So it's frustrating. So anyway, onto the bugs caught. So this one's tough to give a useful answer for because it's stuff I was finding as I was writing features. It's also partly a design tool where I'd go to write the test and realize I need to change something to make it work with the test. So like, oh wait, I need to fix that in order to write the test in the first place. Cool, all right, cool. And it ends up this sort of circular thing where you're modifying tests to modify code to modify tests to, it's a sort of a design tool for writing the code in the first place, as well as checking it afterwards. The JSON round tripping I showed found bugs with, I found a parsing bug, then a generator bug, then a parsing bug. I was not including IDs at all, and I realized, oh, design decision, I need to figure out how to include IDs in this thing because that's something I hadn't actually thought of at all and stuff like that. And so informed my sort of the development process and caught stuff on the way into getting to a production result. Similar to idempotent actions. I run across a couple of edge cases in terms of basically the conflict stuff involving the database, and it's like, okay, cool, I'm really glad I had a bunch of different test case examples being thrown at it. I've got an example from that some people might have seen before, but when I was getting to property test back before I started doing Haskell, back when I was doing Ruby and PHP, was a zip file thing where I was, please don't read the entire thing, but a property test that described like generating a random zip file with generating random file names, with generating random contents. And what I ended up doing was with a really long file name, I could generate using this library, RubyZip, a zip file that it could create but then couldn't open. I was like, okay, cool, it's genuinely a bug. I'm happy to report this one. And as icing on the cake, I then used it with 7-zip and found a segmentation fault, which turned out to actually be a security problem. I was like, oh, that's really nice. I'm really glad that someone found this. Turns out really long file names inside zip files were not handled by p7zip very well at all. But yeah, I'm going to wrap this up now. What's the answer on actually using stream data? Boy, this is a very conditional answer. 3 answers. Yes, if you have someone on your team who's already used property testing before and is already across how you use generators, how you compose generators to design things to make it easier to write tests. Someone who's gone through this gauntlet in whatever language with whatever property testing toolkit is a arguably really valuable asset, and I think you're going to run into a bunch of problems without it. A tentative yes if you don't have that person, so long as you keep it isolated to particular cases. Use it as an experiment, see if you like it, but have it very much something that you can rip out this one test later on if it turns out if it's not actually working for you. And frankly, no if you don't want to get off the beaten path. I'm not just talking about the JSON API stuff because I realize you can make that work. It's just unfortunately you can't. It's more difficult to wrangle. But like the stuff like factories, like, okay, this is weird. Do I put my engine? It's basically there's no guidebook for this in terms of working with Elixir, with Phoenix and Ecto. There's no guidebook for that. There's definitely guidebooks for learning how to do property testing in more general senses across different languages, across different toolkits. But it's a case of there's nothing written for Phoenix and Ecto as far as I can tell. In terms of reference material, in terms of learning material beyond people's sole experiments and posting particular tickets and things. And definitely start with the things that are easy to generate data for, or you want to test the crap out of that you know that you've got something where you want to hammer it with a whole bunch of different permutations, and you can think of ways of designing those permutations such that you can get a useful test out of it. There are definitely things that I would automatically go for property testing for, and just unit test for the rest of the system. This is definitely where they're having experience of having used it on some small stuff will definitely guide you towards what is actually appropriate for doing property tests. And yeah, I realize this talk is a bit of draw the rest of the fucking L. I'm very sorry. But I try to get into as much detail as relevant for half an hour of talk. I'm sorry, I went over double. I'm very, very sorry. But yeah, that's my experience report with property testing, and there's a couple of decent guides out there. Beyond the stream data docs is the proper testing, which is a very detailed guide. Basically, it's written for Erlang testing libraries, but I've gotten use out of it for my own non-Elixir and non-Erlang sort of testing work. Anyway, I don't know if we want to take questions or just take it to the pub, but otherwise, thank you very much. Oh dear.
Time for a couple of questions.
Okay.
Comment also on the question.
Get out.
My experience, I have a relatively limited experience in property testing. I'm using a couple of side projects. But my observation is it's very powerful if you've got sort of as close to a pure function sort of situation. Like it's not hitting the database, you don't need all this set up. It's like I've got an input, an output, I want to make sure that with lots of different inputs, the outputs give me what I expect. So my experience was using it with some cryptography stuff. So I'm encrypting a value. I want to make sure that when I decrypt the value, I get the original value. That kind of stuff works really well. I found trying it with doing lots of setup to vector like Phoenix and stuff, I found it intolerable. So that's just my experience.
Okay. A brief counter commentary. Well, not counter. I've definitely used it on things that are stateful, in terms of stuff that uses state, not necessarily stateful testing, which is an entire bucket in itself. I definitely agree. It's easiest to use when it comes to pure functions, but I've got a lot of value out of API testing stuff. And there was actually a really good talk. God, I can't remember if it was Lambda Jam or ComposeConf this year, where it was about testing WordPress using property-based testing. And basically like interacting with real-world systems, as well as on top of the Erlang-based, so the Cubic quick check stuff, which is in Erlang. John Hughes' sort of experience with testing very, very stateful black box stuff with Toyota. So I've got some experience using on my own using against black boxes, using against stateful stuff. But I agree, it's definitely easy to get started when something's pure, and it's definitely screwing around with, make sure the database is set up right, you know.
Could be an interesting experiment. I don't know if anyone's tried this, doing like gen server testing.
Yeah, that's
Manage your state and just test the hell out of
that's
it.
what I wanted to say. That the Phoenix and so on, seems that it's not for that. So if you
Sorry?
don't have a money for quick check, they don't have state machines.
Mm-hmm.
So for testing the processes and so you need a state machines. Quick check have that. What you generate state machine of the messages that you send to the gen servers, which is Phoenix is and Black is, and Hector, you generate the messages that you pass there, and it's built using the state machine of all possible and impossible messages that it's guessed, and when it's crashed due to overflow in the inbox, due to the incorrect sequence of the messages, of the double messaging and so on. So the stream data does not have any plans whatsoever to do state machines in that way. So only quick check so far, which is paid, not helpful.
Yeah.
From Haskell.
So to be clear, state machine testing, as in where you state a bunch of like preconditions, postconditions, etc., representing different steps, is different to testing stateful things, which is what I do with the controller. I just want to make it clear because it's terminology kind of overlapping, where you can test a controller, and that's arguably very much not pure. It's hitting a damn database, etc. But there's definitely an entirely different realm of property testing. There's state machine testing that is separate, and there's pull requests and issues. Some guy was trying to introduce a state machine testing to stream data. I have no idea what the hell it is, and it's basically almost an entirely half of a framework on top. But yeah, and Cubic is very featureful and very expensive.
There's also
Sorry.
a book.
Put your hand into it.
Yeah, like a third word.
Like everybody else.
That's cool. Who was? Sure.
That's a fairly quick one. Do you ever
Sure.
find that your entropy pool on your machine runs out?
I have not found that one.
So you haven't
I don't know. I may be over.
or anything like that.
Yeah, it hasn't sat there and blocked. Maybe it's using the thing that doesn't actually care all that. Like there are the two versions, the one that blocks and the one is like, it's not quite random, but who gives it?
Okay.
Maybe. I haven't personally run into it on any of my property testing experience so far. Sorry?
I was going to ask, have you come across any libraries of predefined properties that you might like that could be reusable? Because, for example, making sure that certain actions are round trippable, or making sure a control action is idempotent, being able to say and being able to just declaratively say in a test, is this module of a library of property tests. This is my controller. Here's the things you have to poke it with. And I want to just say import idempotent controller property. Make sure it works.
Useful security testing stuff.
Yeah, because then you could, like, the actual, some of the logic could be reusable. And
Yeah, I agree. Yeah.
Go, here's a suite of things that we've defined, reuse them. If no one has done that yet, that could be an interesting project.
Cool. I think Elixir Camp is coming up. Sorry?
Don't a lot of the
I'm not going, but-
libraries have
Yeah.
some property testing as part of the library.
There's some libraries have property tests as in the same place you put unit tests for a library, and some have laws which are basically auto-generate a bunch of cases for things that are very defined in how they behave. But there's no equivalent in Elixir, or you could, but nah.
I guess if it's never going to get into core, then it's unlikely to happen.
Yeah, and I'm not really sure how I feel about the not getting into core, but it's like baking it in, but also would help the adoption. But do we want to adopt? Look, I don't know. I have conflicted feelings all over the shop. Sorry, last question.
For package name like stream data, it doesn't exactly sound like a test library. Does it do stuff outside? Yeah.
Yeah, it's basically. I mean, it's what it sounds like. You can use it as a stream, as in you can just keep asking for strings until the cows come home. It's just a way of defining things that sort of generate data when you ask for them, as in like pull streams, I think is probably the terminology.
The reason they called it stream data was it was supposed to have a dot in it when it got pulled into core.
Oh, right.
And X unit properties was also supposed to have a dot.
X dot unit dot properties. Yeah, okay. That.
They named it explicitly so you could literally just add a dot once it was in core. But it doesn't seem like they're going to put it in there.
I was more so wondering as like how useful it is outside testing, but like.
I don't know. I mean, if you use like the lazy stuff from Ruby, for example, like lazy arrays is probably it's definitely that's definitely an analog in stream data. Help, sorry, I'm again like a 6-month newbie of Elixir, so.
Like a faker gone on steroids.
Yep.
That is still
Testing, but yeah.
we use
sample
generators
data,
like that in Python for simulation work.
Yep. Okay. Simulation of test environments or simulation in
Simulation of businesses that we then
okay.
we're then trying to prove that an algorithm works on a when we're simulating queue management systems or something like that.
Cool. That's good.
A key part of the generators is it throws the stuff out in a particular way, and then once it hits failure, you can shrink it back down again. So if you don't need both those properties,